You are probably sick of new formulas by now, but this is the last section in this chapter with new formulas. We are dealing with spheres this time. Technically, a sphere is the set of all points in space equidistant from a given point. That definition is fine and all, but you probably already have a good sense of what one looks like. You probably have seen spheres since you were a tiny baby, and your parents gave you a ball to play with. Here are some examples of spheres. But you probably already knew that. Now we have a bunch of vocabulary that deals with spheres. In the definition, this was referring to the center of the sphere. But even beyond that, you probably could have guessed where the center of a sphere was. The center is, well, in the center. A radius is also one you probably already could have guessed. This is the official definition, but you won't need that. All of these are radii of the sphere. Probably not much of a shock. Diameter is just like you would expect. All of these are diameters of the sphere. This shouldn't be a shock either. Whenever a plane passes through a sphere at more than a single point, the intersection is a circle. So on the left, if a red plane passes through the circle like this, then the intersection of that red plane and this sphere is a circle. If a blue plane goes through the middle sphere, its intersection is also a circle. Note that since the blue plane passed closer to the center of the sphere, the blue circle is bigger than the red circle. Finally, we have a green plane passing through the right sphere. This time the intersection goes through the center of the circle. This intersection is as large as it can possibly be. In situations like the green one, where the center of the intersection is also the center of the sphere, it is called the great circle. Now the term great circle isn't used very often, but it is used in the next two definitions. First we have the circumference of a circle, which is the circumference of the great circle. So the circumference of that green great circle would count as the circumference of the sphere. A hemisphere is half a sphere. A great circle splits a sphere into two hemispheres. The most common usage for hemisphere is when you refer to Earth having a northern hemisphere, southern hemisphere, eastern hemisphere, or western hemisphere. A quick side note which some of you have been wondering about. A semicircle is half a circle. A hemisphere is half a sphere. Why are there two different prefixes? Why isn't it hemicircle or semisphere? Now granted you aren't used to saying it that way, so it probably sounds weird, but that's just because you aren't used to it. What's the reason why they don't use the same prefix? Here's why. Semi is a Latin prefix meaning half. Hemi is a Greek prefix also meaning half. The word circle is of Latin origin, so it gets the Latin prefix semi. That's why it's a semicircle. The word sphere is of Greek origin, so it gets the Greek prefix hemi, hence why it is a hemisphere. So for the handful of you who have been wondering about that, there's your answer. First we have the surface area formula. The surface area of a sphere is 4 pi r squared. Exactly 4 times bigger than the area of a circle formula. That's kind of odd. Think about it this way. Here I have that sphere again with the great circle highlighted in green. Let's say that the radius of both the great circle and the sphere is r. That means the area of the great circle is pi r squared. This means it takes exactly 4 great circles to make up the same area as a whole sphere. That's pretty odd and interesting. Well, at least to me. If you couldn't care less, then just remember the formula. Now to the last formula in this chapter. The volume of a sphere is the somewhat ugly looking 4/3 pi r cubed. Note that this is r cubed, not r squared. Keep that straight. That's one of the most common errors with this formula. Just remember, area's units are units squared, inches squared for example, and the area formula has an r squared. Volume's units are cubed, feet cubed for example, and the volume formula has an r cubed. If that helps, great, but somehow you just need to keep them straight.